Hello and welcome to SudoKanard. I'm very proud to present to you a puzzle that I made a few weeks ago, which is entitled Sanwich Sudoku with Quadruples. And here it is. So I just recapitulate what the rules are. Well, the usual Sudoku rules apply. And then there are those sort of given digits, except that they're given on a global scale, meaning that those four digits, 1, 2, 3, and 6, have to be placed in those four cells, and the same goes for those four cells. That's what is called quadruple Sudoku. And then you have those external clues. Oh, I forgot to mention something. So I write it down while I pause the video. Ta-da! So the magic of editing has allowed me to add some more sentences to the rule set. So those outside clues are sandwich sums, meaning that this 33 is the sum of those digits on this row that are sandwiched between a 1 and a 9. Well, what I've drawn is impossible actually, but the point is that wherever you have the 1 and the 9, the digits that are sandwiched strictly between the 1 and the 9 must add up to the number that is in the margin. On some columns or rows, nothing is specified. It means that you don't need this sum to solve the puzzle. And on two rows, you have a minus sign. That does not mean that the sum is negative, which would have no meaning. It just means that the sum is not zero. Those may be zero, they may be non-zero, but those may not be zero, they must be positive. And that's it for the rule set. Now, how do you solve this? Well, obviously you know that those four digits are here, those four digits are here, but you don't need to pencil mark them as they are already pencil marked, obviously. Let's start by stating something that is very important in all regular Sanwich Sudoku puzzles, which is that the sum of all digits between 2 and 8 is 35. That is important because that's the biggest sum you may encounter for a sandwich sum, meaning that those two sums are very big. They are almost maximum. It means that only the digit 2 is outside the sandwich on this row, and only the digit 3 is outside the sandwich in here. So what you may have is something with digits 1 and 9 in here, and the missing digit here, or digits 1 and 9 here, and the missing digit here. And the same goes for this 32, because only the digit 3 is missing, so it's the same. You have 1 and 9 in those cells with the missing 3 outside here, or 1 and 9 in those cells and the missing 3 here. So 1 and 9 are somewhere between these cells, here and here. And something that has been said a lot by Simon Anthony on Cracking the Cryptic is that it is a good practice to highlight those cells that can't contain a 1 or a 9. And instead of highlighting the digits, because I don't have such a clue, I just put some symbol in the corner, meaning that this is forbidden, meaning that you can't have a 1 or a 9 in those cells. So the exact position of those 1s and 9s must be determined, but you should note something. This 16 clue means that it's not possible for both those 1 and 9 to be here and there, because then you would have only one digit sandwiched between the two, and the sum wouldn't be 16. And here the same applies. You couldn't have a 1 and a 9 in both cells because this digit should be 24, which is not a digit. So the conclusion is that those 1 and 9 digits should be here and there, or here and there. And same goes here and there, or here and there. So we already know this, but which way this has to be determined yet. Next thing, let's have a look at, oh, what's happening? Where has my pointer gone? Oh, there it is. Let's look at this 3x3 block. We know that there must be a 1 and a 9 in this 3x3 block, and they can't be here or there. So they have to be among those cells. And here, this clue comes into play. It means that the sum of all digits between the 1 and the 9 is not 0. So 1 and 9 can't be next to each other. So there must be a digit between them. So 1 and 9 have to be in those cells. Now, we can safely say that all the other digits on the row are not 1 or 9. Now, let's have a look at those columns, because we now know where one of the extremities of the sandwich, one of the ends of the sandwich, the crust, yes, one of the ends of the sandwich lies. And we need a sum of 20. And something to note is that with only 2 digits, you can only have a sum of 15. So to have a sum of 20, you need at least 3 digits. And now, if you need 3 digits starting from here, ending to the other end of the sandwich in this column, we need 3 digits. So 1 and 9, the other 1 and 9 can't be in those cells, and the same goes in the other columns. Well, when I designed this puzzle, I initially wanted to have all those sums equal to 20, but I settled for something less spectacular. So that's something. So we know now that there is one end of the sandwich here or there, and one here or there. They can't be both here, because once again, this 13 clue says that, well, if they were there, then we would need to put a 13 in this, and it's not allowed. So at least one of them is here. But something else is important. This 19 clue says that it's impossible for both ends of the sandwich to be in here, or for both of them to be here, because there would only be one digit and 19 is much too big. So we need to have one end of the sandwich up there and another down there. And something else is that a 19 clue is not possible with 5 digits in a sum, because if you add up 2 plus 3 plus 4 plus 5 plus 6, which is the minimum for a sum of 5 digits, it makes 20. So this 19 means that it can't be a sum of 5 digits. It has to be 3 or 4. And a sum of 3 digits would be with the ends of the sandwich here and there, and 4 would be with the ends of the sandwich here and there, or here and there. And in every instance, you see that these cells can't have the end of the sandwich. I'm not sure that's so important actually. I don't remember the full details of how this puzzle is meant to be solved. It's been a few weeks, so I'm making this up on the spot. Now we know that there must be one end of the sandwich here and the other one in here. So 1 or 9 somewhere here and 1 or 9 somewhere here, and the same here. Let's have a look at this 24 clue. 24 can include 5 digits, and it cannot include less than 4 digits, because the maximum you make out of 3 digits is 21. So we know that the 24 sum is somewhere, it can even have 6 digits actually. It can be 6 digits. It could be, or could it? No, 6 digits is at least 27. So no, it has to be 4 or 5 digits. And so it could be here with the other end here. It could be here with the other end here. It could be a 1 in here. So this 24 does not seem to be so important at this point. What about this 21 clue? This 21 clue, it could be a sum of 3 digits. It could be the sum of 4 or 5 digits, but it couldn't be 6 digits. That's not so. No, I don't think that's what I'm supposed to look at. What was the next step again? Oh yes, something important about this 20 clue. I forgot about this, and I shouldn't delete that. You see that the most you can make out of 3 digits is 21 with 8, 7, and 6. So there's actually only one way to have a sum of 20 with 3 digits, and that's with 8, 7, and 5. And that is sort of important because we know that all those digits are 8, 7, and 5. In here or in here. So we know that those two digits are among 8, 7, and 5. And there's something with this 19. There are 2 possibilities for 19, and those are 8, 6. If we assume that 19 is made of 3 digits, then there are only 2 possibilities, which are 8, 6, and 5, 8, 7, and 4. And I seem to remember that, I think I remember that neither of those is possible. Because if I put, let's say, 8, 6, and 5 in those cells, then how can I have 2 digits in here or in here that would be among 8, 7, and 5? This is impossible because they both would have to be 7. And if I put 8, 7, and 4 in there, then the same logic applies. It means that you already have 8 and 7 here, and both digits of those sandwiches that lie in this 3 by 3 blocks would have to be a 7, and that's not possible. So this is to mean that this 19 cell actually uses 4 clues. 4 digits, I mean. It has to be the sum of 4 digits. But is this useful right now? I'm not so sure. What can we say about this? That the 1 and the 9 in here are in those cells. Oh, and here we have a 1 and a 9 as well. And we know they are in different columns. So we know that here 1 and 9 must be in different columns. And they can't be both here because of this clue which says that on this row 1 and 9 must be separated by at least 1 cell. And the same applies here because of this 13. So they are in different columns and they can't be here and there, so they have to be on some diagonal, here or there. That's the first thing. So there's one of them here, one of them there. And now we know that there are 1 and 9 here, 1 and 9 there. So we know that 1 and 9 are not here. So they have to be both here on this column. And there are no 1 and no 9 in there. And that is something because we need a sum of 16 on this column. And 16 needs at least 3 digits because 2 digits have a maximum sum of 15. So we can't have one of them here because from here to there, there's only 2 digits for a sandwich. So we know that one of them has to be here. So there's a 1 or 9 here. Sorry, I choose the right color. 1 and 9 here. And we now know that on the same row, 1 and 9 are placed this way. And the missing digit is in a 2 here and a 3 there. And those digits have been used to their maximal potential. That's true of this one as well. Well, now we need at least 3 digits. Well, those have had to be excluded anyway. But we don't know yet whether it's a 3 or 4 digit sum. So we are not sure exactly where 1 and 9 go in those cells. But let's have a look back at this 24. We know that the sum must include at least 4 digits, so it can't be this way, it has to be upwards. And those cells can't include a 1 or a 9, and this cell has to. And because of the choices around this circle, it has to be a 1, giving us a disambiguation for those 1 and 9 pairs. And now those digits must add up to 24. And we'll have a look in a moment at what those digits can be. First, I rule out some cells from being ends of a sandwich. Now let's have a look at those cells that can't be ends of a sandwich. This 18 clue needs a sum of at least 3 digits, sorry. So they can't be this and this cell. They have to be this and this one, this and this one. Maybe those 2 cells, but no. 5 digits would add up to at least 20. So it has to be a sum of 4 digits here and there or here and there. Except that this can't be a 9. Oh, I should have ruled out those cells from the beginning. And now you see that the only possible way of fulfilling this clue is to have a 9 here and a 1 there. And those digits must add up to 18. And now we know that there's a 9 somewhere in there, and there's a 1 here. And we've seen that this 19 sum uses 4 digits, so the 9 is here. Now this 1 or 9 must be a 1, and it can't be here, so it has to be there, and the 9 is there on the other side of the diagonal. What can we say more? What more can we see? Those cells do not have a sandwich end, so on this row the 9 must be here. And you can see that on this column the sum is 0. On this column the sum is not 0. What can we do next? So these two cells must be 3 and 7 in some order. Now this 13 clue needs a 1 somewhere here or there, but it has to be 3 digits or 2 digits or 4 digits. But the minimum sum of 4 digits is 2 plus 3 plus 4 plus 5, and that's 14. So the 1 can't be here, it has to be there. Now, those are not 1 or 9. And those 2 digits must add up to 13, which makes this a 7 and this a 6. These clues have been used to their full potential. And this one disambiguates this 1-9 pair. Now we should be almost finished with the 1s and the 9s. We only need to place them in this area, and you see that they can't be on those rows, they have to be here, and because of this 1 and this 9, they have to be this way. So now, well, I fill in the remaining cells, and I do this so as to highlight, to really, or maybe I should remove all these ugly little bars and just highlight the 1s and the 9s for the rest of the soul. I do that by pausing the video. I just noticed that I forgot to put a 9 in the grid, and it's here. So now I've highlighted in a very clumsy way all those 1s and 9s, and now we must solve the Sanwich Sudoku. Where do we start? We know that those digits must be 1, 8, 7, and 5, so I pencil mark them this way. What is this glitch? We now know that those must be 2, 3, 4, and 6 in some order. Something else is those are 2, 3, and 6, and because of this 3, we've got a 3 here and 2 and 6 there. Those 3 digits must have a sum of 21, and the only way is with 6, 7, and 8. So this is 7 or 8, 6, 7, 8 in those cells. Down there we need 2, 4, and 5. With this 3 and this 3, we have a 3 here. Let's do some calculation. Those digits add up to 21, and all digits apart from the 1 and the 9 add up to 35. So that's 21, 24. We need another 11 with those digits. We can't use a 3. We can't use a 9, obviously. So it has to be either 7 plus 4 or 6 plus 5. And it doesn't seem to be very useful. So I have to come back to this later. This 16. So we have 16 plus 7, that's 23. We need another 12 here. There are many ways to produce this 12, I'm afraid. So we don't have much to go on. Oh. So, this, we know there's a 6 in here, so there's no 6 here. There has to be a 6 here. And we say that the outside digits must add up to 14, so this has to be a 5. And now we have 7, 8 in those cells, so this is a 5. And those digits must be 7, 8, and 4. We need a 2, so 2, 4, 7, and 8. And this has to be a 5 because of this 5. Down there, there are 7 and 8, and with this 7, this is 7 here, 8 there. So no 7 here, and this is a 4. This is not a 4. The remaining digits must be 2, 3, and 6. Here are 2 and 3, that's a 6. 2 and 3 in the other cells. On this row, we need 4, 5, 7, and 8. Not very useful again. There's a 6 somewhere in there, but... Oh, there must be a 3 on this column. It's not here, not here, not here, so there's a 3 here. And the other digits must include a 6. 6 is not here nor there, so here is a 6. And down there we need 2 and 4. And, oops, by Sudoku 6 goes there. And this is not 2 or 4, so it has to be a 5. Making this an 8, this a 7, and this a 5. And this not a 5. On this row we need here 2, 4, or 5. On this column, 6 is not here, 6 has to be there. 2, 3, 4, and 6. Not quite resolved yet. That's the central column begins. It might be possible to solve that. We have 19 on the inside, so it's 16 on the outside. The sum must be 35. So 16 on the outside, there's a 5, we need another 11. Without using 5 or 6, but that's not so useful. It could still be 3 plus 8 or 4 plus 5, 4 plus 7. But, oh, we need 18 here. How do we do that? How do we do that? if this is an 8, we need another 10 without using 8 or 3, so it will have to be 4 and 6. So it can be 4, 6, 8. But if I put a 7, I need another 11 without using 5 or 7, and without using 3. So without using 5, 7 or 3, and 9, and there has to be an odd digit, so it's not possible. Actually, 7 is not possible. So this has to be an 8, that's a 7. And the sum here must be 10 without using 8 or 3, so it has to be 4 and 6, and with this 6, that's 4 here, 6 there. It fixes the 2, 6 pair. 2, 3 and 7 in here, 7 is here, 2 and 3 there, a 4 here. This central triomino must have 2, 3 and 8. So 3 or 8, 2 or 8, 2, 3, 8. And as you can see, we really don't need, well, we didn't need this clue, we didn't need, well, it still remains to be proved, I think. On this row, 5 is not here, it has to go there. I remove this 5, and now on this row, 5 can only be here. Three, 6 and 8. 3 and 6 can't be here, so it has to be an 8. And it allows for some cleaning, so some cleanup, I think. Those must be 2 and 4. I need a 7 on this row, it can only be here. This is not a 2, so it has to be 4 or 8. We're slowly getting there. Those digits must be 5 and 7, and with this 7, it is like this. Those 5s give us a 5 here. We need 2, 4 and 8. This column still needs a 4 and an 8. So this is 4, 8, 4, 8. This 6 puts a 6 in here and a 3 there. How can we fulfill this 16 clue now? We need another 10. 4 would have the 6 to repeat, so it has to be an 8 and a 2. And 8 goes there. So now it's almost done. I do some cleanup. There's a 4 here, an 8 there. This is a 3, that's a 2, that's a 3. And the 2 remaining digits must be 4 here and 2 there. And we can check that this does have a sum of 19, indeed. And I don't think I checked them all. And so you could have the impression that we didn't use the 19 clue, but actually we did use the fact that it had to be a 4-digit clue and not a 3-digit clue. This is how we placed the 9 here, if I remember correctly. So this is the end of this wraps up the solve of this Sanwich Sudoku with 2 quadruples that I created a few weeks ago, and I must say I like it. So I hope that's not too arrogant. I really like the puzzle. I really enjoyed solving it after a few weeks. So thanks for watching this video. I will soon have a break of a few weeks on the channel, and a few weeks, not sure if it will be a few weeks or a few months. It will depend on some stuff which I have no control upon. So thanks for watching this video, and see you at some point on SudoKanard.